Hello, my name is Alan, and my project was about adversarial machine learning, specifically developing robust and secure machine learning models. Special thanks to Professor Brent for overseeing my project, and Dat, the student who worked on all the constraint-solving logic for the backend, as well as the data gathering. To start off, let's go over the background of adversarial machine learning. Machine learning models currently have a lack of security and robustness testing, which makes them vulnerable to attacks. There are many different attacks that can be performed on these models for the benefit of attackers. For example, in the realm of machine learning image classification, which is the focus of this project, a common reason to attack models is to trick them into misidentifying certain types of images. Attackers may want to do this in order to affect face recognition, for example. Theoretically, you could do this so that terrorists could avoid getting recognized by facial recognition. To make matters worse, these attacks can go completely unnoticed, so the company using the model is completely unaware that their model has been jeopardized. So you can see that the current lack of security is a problem, and that it is important that we do something about it. The initial objective of the project was to determine what a secure and robust model means, which involved research. But the bulk of the project was spent on the second objective, which was to develop an end-to-end product capable of storing data about models and giving defense recommendations for those models. The motivation for this product was to provide developers with a tool for estimating the pros and cons of different defenses for their model. We also wanted to show developers the importance of defensive techniques for models. And finally, we wanted to strive to balance the computational versus security trade-offs in end-to-end systems. What I mean by this is, we want to balance the performance of the model and the security of the model. For example, you might have a defense that proves extremely effective against attacks, but adds many seconds to the inference time. In the case of a self-driving car, you can't afford to be adding many seconds to your time that it takes to make a decision. Another aspect to consider is training time. If a defense is adding days to the training time of a model, this would have a high financial and environmental cost due to the massive amount of electricity needed to run the GPUs, which would not be very practical. You need to balance the time with the effectiveness of the defense. Here are a few of the challenges that I faced. First off was learning Python and Kiwi, since I was new to those languages and needed to learn them on my own. Kiwi especially was harder to pick up because it's not as popular or polished of a language. It was also hard not only to decide how to be user-friendly, but also to then implement those features to be user-friendly. The autocomplete feature especially was a challenge to implement and something I will go over in the demo in a bit. And of course, the rigorous task of refactoring throughout to ensure good coding practices. In terms of accomplishments, we accomplished creating the end-to-end product we wanted, capable of storing model data and giving recommendations. I also created documentation to support the future development of this project, and I will get into the future plans for this project a bit later. The process I followed to complete the capstone was first researching machine learning attack and defense concepts to familiarize myself a bit with the world of machine learning. Then I brainstormed features for the user interface, and with those features in mind, I designed possible layouts for the user interface. And finally, I developed the user interface, implementing the features that were brainstormed. The main technologies used in this project were Python, Kiwi, and GitHub, and I coded using the PyCharm IDE. Next, I will be presenting a very brief demo of the product, just over a minute long. To start off, I'm going to boot up the application, and I am brought to the menu. First, we will look at creating the input data file in case the user doesn't already have one. You can see here that as I am typing, there is an autocomplete feature which I can use to more quickly and accurately fill out the form. If you already have an input file, you can also load one, which will be shown here. We're going to go back, and now I will show the creation of the settings file. To speed up the process, I will load one. Now let's say I wanted to change one of the values. I can do that. And now we will save this file and we will call it Capstone Demo. Save it and click Finish. And now I will choose the file that we just created. And you can see here that it is the file we just created called Capstone Demo, and we click the Generate Recommendations. So here we have the defenses that are recommended for each attack. And in the demo, we are using a relatively small input file with only 2 attacks, so there are only 2 recommendations, but you can use much larger files. For future work, there are still things to improve, such as restricting the user's ability to make errors, enhance the aesthetic, improve the performance, and develop for other platforms such as web-based, which would expand our capabilities. For lessons learned, I learned Python and Kivy, the JSON file structure, GitHub, and various machine learning concepts. And I even got the skill badge for Python on LinkedIn. That draws this presentation to a conclusion. Thanks for listening.